Morning once again. Today this video is going to be my fourth video on the chapter polynomials. In the last video already you have solved some questions from the exercise 2.2, correct? Now today in this video we are going to finish the exercise. In this video we shall solve question number 2 ka Roman 1, Roman 3 and Roman 4 from the same exercise 2.2. Then it will be completed almost. But before that, first let us read the question. What is told here? Find a quadratic polynomial each with the given numbers as sum and product of its zeros respectively. That means in this case the sum of the zeros and the product of the zeros of a quadratic polynomial will be mentioned. From here we have to find out the quadratic polynomial. So that is to be done here. Now let us solve one by one, correct? Look at the question number 2 ka Roman 1. First let us see what is given here, what is mentioned here. Here the two numbers are mentioned, that is 1 by 4 and minus 1. So what is the 1 by 4 here? It is the sum of the two zeros. It is already mentioned. At the same time the minus 1 is mentioned. What is that? It is the product of two zeros. Now from here you have to find the required quadratic polynomial. So how to start first? Here the starting is very important. Now let us see how to start. Let the required quadratic polynomial is x square plus bx plus c with the zeros alpha and beta. So you have to start in this way. Let the required quadratic polynomial is x square plus bx plus c with the zeros alpha and beta. Now the question may arise, why we assumed this quadratic polynomial? Because we know the general form of a quadratic polynomial is x square plus bx plus c. That's why we need to start in this way, correct? Now look at here. Here a, b, c are unknowns, so you have to find the value of a, b, c somehow. Then our job will be done. Now the question is how to find the value of a, b, c. To find the value of a, b, c, the two hints are already mentioned, so you have to use them. Now what is told here? 1 by 4 is the sum of the two zeros, and already we assumed the two zeros. What are they? Alpha and beta. So the sum of the zeros means alpha plus beta. That is already given, 1 by 4, correct? Similarly the product of the two zeros means alpha into beta. That is already given, minus 1, correct? And already we know, because we had two relations from the previous video. Already we learned in the previous video. What we had? We know alpha plus beta equal to minus b by a, correct? Similarly alpha into beta equal to c by a. So we had these two relations. Here alpha plus beta equal to 1 by 4, and here we see alpha plus beta equal to minus b by a. So you can say minus b by a equal to 1 by 4, correct? Now multiplying minus 1 with the on the both sides, it becomes b by a equal to minus 1 by 4, correct? Now this minus will go to the numerator, it becomes minus 1 by 4. Now comparing on the both sides. On comparing you can say a equal to 4 and b equal to minus 1, correct? So in this way we have got the values of a and b, a equal to 4 and b equal to minus 1, correct? Only c is remaining to find. So how to find the value of c? To find the value of c, let us use the one more relation. We know alpha into beta equal to C by A. Correct? Already alpha into beta is mentioned, that is -1. So we can say from here C by A equal to -1. Correct? From here. In the previous step already we have got value of A, that is 4. Now put down here. It will become C by 4 equal to -1. Now let us doing cross multiplying. It will become C equal to -1 into 4 means -4. So in this way also we got the value of C, that is -4. So here we got A equal to 4, B equal to -1 and C equal to -4. Correct? And what we assumed? The required quadratic polynomial is x square plus bx plus c. And already we have got the values of a, b, c in the previous step. Now put down all the values here one by one. Now put a equal to 4, it will become 4 into x square. Put down b equal to -1 here, it will become -1 into x, and c each -4. So ultimately we have got 4x square minus x minus 4. That is the required quadratic polynomial that we are looking for. Understood? In this way you have to manage this type of questions. So how it will be remembered, these questions? We have to do practice 1 or 2 times, then it will be understood properly. Now let us come to the next question. Let us come to the question number 2 ka Roman 3. Here similarly 2 numbers are mentioned, 0 and √5. What is 0 here? The sum of the 2 zeros, and the √5 is the product of 2 zeros. From here you have to look for the required quadratic polynomial, right? And we know how to start. Here the starting is very important. So let us look again. Let the required quadratic polynomial h, QP means quadratic polynomial, h x square plus bx plus c with the zeros alpha and beta. Correct? So you have to start in this way, where a, b, c all are unknowns. To find the value of a, b, c we have to use these 2 given hints. Now let us use. Already we have assumed the 2 zeros of the given quadratic polynomial alpha and beta. So here the sum of the zeros will be alpha plus beta, and it is already given here 0. Correct? Similarly the product of the zeros will be alpha into beta, which is already mentioned here, root over 5. So we have alpha plus beta equal to 0 and alpha into beta equal to √5. And already we know from the previous video, already we have learned in the previous video, alpha plus beta equal to minus b by a. Correct? Similarly alpha into beta equal to c by a. We have 2 relations between the zeros and coefficients. Alpha plus beta equal to minus b by a and alpha into beta equal to c by a. Now here alpha plus beta equal to 0 and here alpha plus beta equal to minus b by a. So we can say the both will be same. Correct? So minus b by a will be 0. So only b by a will be 0 because we are multiplying -1 on the both sides to remove the minus. Now this 0 can be written as 0 by 1. Correct? Now on comparing on the both sides we get this will be equal to 1 and this b will be equal to 0, right? Means we are comparing numerator to numerator and denominator to denominator, correct? So in this way we are getting the value of a and b. We got a equal to 1, b equal to 0. In the similar way, now only c is remaining to find, correct? So how to find the value of c? Now let us use one more relation to find the value of c. So we have alpha into beta equal to c by a. Also we have alpha into beta equal to root 5. So we can say it is equal to root 5. From here only c by a will be equal to root over 5. Now look at here. In the previous step we have got the value of a, that is 1. Now let us put here. It will be equal to root over 5. Now let us doing cross multiplying. It will become c equal to root over 5 into 1 means root over 5, correct? In this way we are getting the value of c also, that is root over 5. So ultimately we got a equal to 1, b equal to 0 and c equal to root over 5. And we assumed the required polynomial is x square plus bx plus c. So here the required quadratic polynomial will be x square plus bx plus c, correct? X square plus bx plus c. Now in the previous step already you have got all the values of a, b, c. Now let us put all the values here one by one. Putting a equal to 1 here, 1 into x square, b equal to 0 here, so put 0 into x, and let us put here c equal to root 5. Now let us calculate. We have got x square, it is the 0 plus root over 5. So that is the required quadratic polynomial that we are looking for. Understood? Now let us come to the last questions, to Roman 4. Look at the similar questions to Roman 4. In the similar manner, here the two numbers are mentioned, 1 and 1, both are 1. Here the first one is the sum of the two zeros and the second one is the product of the two zeros. In the similar manner, from here we have to find the required quadratic polynomials. Now let us start. Let the required quadratic polynomial will be x square plus bx plus c, correct? With the zeros alpha and beta, correct? Here ABC are unknown. We have to find the value of ABC in the similar manner. To find the value of ABC, we have to use these two hints. Right? Now let us use these two hints. Since we have assumed already the two zeros, so we can say the sum of the two zeros will be alpha plus beta. And already it is mentioned, that is 1. So we have alpha plus beta equal to 1. Similarly, the product of two zeros will be alpha into beta. And it is already mentioned, that is 1. So also alpha into beta equal to 1. And we know alpha plus beta equal to minus b by a, and alpha into beta equal to c by a. Since alpha plus beta equal to 1 here, and here alpha plus beta equal to minus b by a, so we can say both will be same. So minus b by a will be equal to 1, correct? So from here only b by a will be minus 1. Just let us multiply minus 1 on the both sides to remove minus 1 here. Now this minus 1 can be written as minus 1 by 1, correct? Now let us compare on the both sides. So on comparing we can say a will be equal to 1 and b will be equal to minus 1. Just let us compare numerator to numerator denominator. So in this way we are getting the value of a and b. A equal to 1, b equal to minus 1. Only c is remaining to find. How to find c? To find c, let us use the another relation. We know alpha into beta equal to c by a, correct? Also we have alpha into beta equal to 1. So we can say from here c by a also equal to 1. C by a also equal to 1. Correct? Now look at the previous step. What we got? A equal to 1. Now let us put here a equal to 1. Equal to 1 as usual. Now let us do the cross multiplying. Then it will become c equal to 1 into 1 means 1. In this way we are getting the values of a 1, b equal to minus 1 and c equal to 1. In this way we are getting all the values of ABC. So the required quadratic polynomial will be x square plus bx plus c, because we assumed this one. But in the previous step already we have got all the values of a, b, c. Now let us put down all the values one by one. Here a equal to 1 into x square, putting b equal to minus 1 and putting c equal to 1 here. Now just let us calculate. It will become x square minus x plus 1. That is the required quadratic polynomial that we are looking for. Understood or not? In this way we have to manage this type of questions. So today in this video I have shown 3 questions on the same topic, and also I have shown how to manage them, how to tackle them. So it will be remembered properly if you practice minimum 2 or 3 times. Understood or not? In this way the exercise 2.2 has been finished almost. Today I stop here. In the next video we shall discuss about the next topic, the division algorithm formula for polynomials. So for these days, please be safe, be healthy, stay home. Thank you very much.